Let me welcome you in our today's session, which is called Deep Dive into Network Traffic with Flowmon Packet Investigator. We will be looking at network troubleshooting use cases. As you know, Flowmon is a tool that brings together network operations and security operations, which means that we're basically serving network performance monitoring diagnostics use cases, as well as network detection and response use cases. Today, the focus is on the NPMD part, and we will look specifically at a tool called Flowmon Packet Investigator. So what is the agenda for today? We'll explain briefly the main differences between network telemetry, meaning flow data, compared to traditional full packet data. We will look at our Packet Investigator tool, at workflows, how you can use the tool, and then we'll jump into live demos. I have prepared two use cases. One will be really live troubleshooting, and the other one will be focused on a PCAP forensic analysis. So let me start with explaining flow data versus packet data. Traditional approach to network performance monitoring and diagnostics is using continuous packet capture tools that are recording all network traffic, which means that it's fairly heavy approach because you need a lot of storage, you need a lot of resources to be able to capture all the network traffic, and you're only able to provide very limited history. But of course, you can be sure that all the details that you need will be captured and will be available for subsequent analysis. On the other hand, with flow data, which is basically a network telemetry that describes individual sessions in the network, you're able to scale even to multi 100G links. So you're able to monitor what is going on in the network, and you're able to reconstruct what traffic was on the network in each and every moment in time. But of course, as these are aggregated network sessions, you don't have by default access to full packet data. So for some troubleshooting use cases, you may really need to go deeper, and you may need to capture a specific network traffic to do the subsequent analysis. And in Flowmon, we actually combine these two approaches. We do network-wide flow monitoring, which is accompanied with full packet capture and packet analysis when needed. So it's not a continuous packet capture, but it's on-demand packet capture for specific troubleshooting scenarios. These scenarios are mostly focused on application layer issues, where there are some problems in application stacks, where there are some compatibility issues between clients and servers. So whenever you need to troubleshoot a specific issue, you will basically run a packet capture, and then you will ask the tool to perform an automated analysis. So then you will be presented with the findings and with the issues that were discovered. So let me explain Flowmon Packet Investigator in more details. The principle, how it works, is on-demand packet capture as the first step. So you have a central user interface when you can control all your traffic captures on all the Flowmon probes that you have deployed across your environment, and you're able to use a simple filtering syntax to focus on a specific traffic that you need. Once the traffic is recorded, you can run the analysis that supports various enterprise protocols. So it's not limited to network and transport layer. It also understands different application layer protocols like DNS, HTTP, DHCP, and so on. once the analysis is completed, you will be presented with a simple report that will explain you all the findings and all the issues. You can use Flowmon Packet Investigator in like a standard Flowmon scalable deployment. So you have a central collector where you access the user interface when you control all the recordings, and the recording as such is performed on individual probes that are deployed across your infrastructure, and these probes deliver full packet data to the central collector. If you need to operate it in a standalone fashion, you can do that as well. All the software can be installed on top of the Flowmon probe, so then you have the recording control, the user interface directly on the probe, and the probe is storing full packet data locally. When it comes to available workflows, there are multiple options how you can capture the network traffic. There is a standard manual trigger, so you log into the user interface and you just capture the traffic that you need. You can also schedule that capture. So if you have an issue that happens 2 a.m. in the night, you can basically schedule a packet capture for a specific time interval, and it will be performed automatically. There is also the API option for automated trigger, which is, for example, something that we use internally to integrate between the anomaly detection system, between our network detection response capabilities with the Flowmon Packet Investigator to be able to capture traffic that is identified as malicious. The last option that you have is to upload a PCAP that you have captured previously by some other tools or even in a different environment. So you can upload that PCAP for subsequent analysis. When you have the full packet data captured, you can either run the analysis to get the report, or you can download a PCAP for a subsequent analysis, for example, in Wireshark. There is one very interesting capability that I would like to explain, which is a rolling capture buffer. So the packet capture can go into the past for a couple of minutes, because the Flowmon Packet Investigator is actually buffering first n, where n is configurable, packets of each flow, and provides a history in minutes. So then when you capture the traffic, you can actually go into the buffer and extract the packets that you need. This is especially important when you use a triggered packet capture based on the anomaly detection. This way you can make sure that you will get the traffic that actually caused the anomaly. This is an example how it works. So packets are buffered together with the flow data, with the flow cache. Buffer size is limited. It usually stores, for example, first 10 packets of each session. And whenever you run the capture, so let's say you want to capture something for the IP address 10.0.0.1, so the capture task will start and will also go into the buffer and give you all the packets that are actually stored in the buffer. Another very important capability of the Flowmon Packet Investigator is automated analysis. So it's by no means a competition for Wireshark. It's really a different tooling where you benefit from a built-in expert knowledge in the system that is able to understand different application protocols. It's able to understand how the protocol should flow over the network in a normal situation. And it's able to detect various issues, various problems or errors, and present those in a human readable and human understandable way. So this way, you're actually able to simplify and streamline the full packet capture and analysis. So you will basically make this available also to like level 1 support engineers, you will be able to do it maybe more quickly rather than doing it manually in Wireshark. So even for an experienced analyst, this is beneficial by saving some manual work. So again, this is not a competition to Wireshark. It's a different tooling that will give you out-of-the-box automated analysis. Let's take a look at some standard workflows. So when you want to capture traffic, you basically start a new recording. You will define the time interval. You can control on which probes the capture will be executed. And then once the capture is completed, you're able to analyze the recording, or you're able to download the recording. There is also the option to upload an existing PCAP for analysis, as I've mentioned. When it comes to filter syntax and traffic capture criteria, there is, I would say, very standard syntax of specific terms or specific keywords that you can use to select IPs, networks, ports, protocols, whatever you need to capture, and you can combine these terms in logical expressions by standard operators like AND or not. You can see some example that will be capturing traffic on a specific IP address 192.168.2.2 on ports 3306 or 3307, where the other communication party is from those 2/24 subnets. So this way you can target your capture and select specifically what you want to capture. Then this way you have access to all the recordings, so you can basically see all the completed and running captures. You can access the analysis, or you can download the PCAP for subsequent manual analysis in Wireshark. When you open the result of the analysis, you will be able to understand what is the structure of the PCAP. You will be able to understand structure of individual sessions, and there is an indication with green, orange, and red color to give you warnings and errors. And whenever you focus on a specific situation, which is basically a specific packet, you will get on the right side more details from that specific packet, extraction of IPs, ports, and these basic parameters. But there is also decoding of the layer 7 information, of the application information, and there is some description and recommendation what you should do to address the issue. So it's time to do a live demo. We will basically simulate an issue on the network, which is based on a real scenario. So at one of our customers, there was a situation that suddenly the UPS stopped sending reports and alerts over the email, and the network admins were not aware of any change or anything that could cause that. So they looked into the network traffic and they figured out the root cause. So what we are going to do in the live demo, we will simulate a similar situation. So we'll try to connect to a server using a TLS version that is not supported on the server side, that is too old, that is deprecated, and we will capture that specific traffic, and we will run automated analysis to see if the root cause of the issue was actually identified properly. So let me go to the Packet Investigator user interface, and let me start a new traffic capture task for this specific situation. So I'll go to new recording, and I need to select the time frame, and I need to do some proper filtering to capture the traffic that I need. So let's say that we will run the capture till maybe 1520 or 1521. That should be enough. And we will filter for a specific IP address of the server. And we will use port 443, so HTTPS. And we also want to analyze the recording automatically. So we know that we are dealing with encrypted web traffic. So I'll select just these two protocols. I don't need to select more. And now when I say start recording, the capture task will be executed by the system. So now the traffic capture was created. And when we look at the recordings, we can see that this is actually my recording. This is the filter that I've used, and it's running, and it will be stopped at this moment. So now what I need to do, I need to simulate the traffic. So I'll use this Linux machine, and what I'm going to do, I'm going to connect to that specific server, and I will connect using TLS version 1. As you can see, there is an error in establishing the session because the server does not support this specific TLS version, as we can see from the error message. So we'll let the capture run, we'll let the tool do the job. And in the meantime, I'm gonna show you a different analysis scenario, and we will get back to this. So in the second scenario, we are going to do a forensic analysis of a PCAP that we already captured. So I'll go again to the new recording section, and I will say that I want to upload a PCAP. And I have here a specific traffic capture again from a customer scenario where there was a compromise and attacker had access to one of the endpoints and credentials of one of the users in the network. And I will run the analysis, and I know that in the PCAP I have Samba protocol, so I'll just select Samba. But basically, if you are not sure what is in the PCAP, you can run all the protocols and it will work as well. So now I click upload. The PCAP was uploaded to the Flowmon system, and it's now being analyzed. So when I go to recording section, I should see that the PCAP is uploaded and probably it's already analyzed. Yes, it says the state is analyzed and I have more than 100 findings. So when I click show analysis, it will basically tell me that there are these errors. There is an attempt to establish a Samba session from the client with the server. They have negotiated successfully Samba version 2. So that's the version of the Samba protocol. Now the client needs to present credentials to the server. So server asked the client to sign in. Client submitted this specific credentials. So this is the username. And then as a result, there is an error identified in the Samba protocol, and Flowmon Packet Investigator gives you the guidance that there is some incompatibility between the client and the server, that the client is not able to properly establish the session and authenticate itself against the Samba server. So it's as simple as that. You're automatically presented with what is the issue and what is the root cause. So let's see if we have already our previous analysis completed. So just a reminder, we have captured traffic for this specific host on this port. You can see amount of traffic that was captured, and you can see the status of the analysis. What we did, we connected using, or we tried to connect using a wget command using a TLS version 1, which is not supported by the server. So let's see what is the result of the analysis. So there was TLS handshake detected between the client and the server. And there is an error in establishing the session because client and server are not able to negotiate the proper TLS version that will be used. So this way you have immediate root cause analysis and you have a recommendation what should be some further mitigation steps. So that's it, and I'm happy to take any questions if you have some. Let me see what I have here. Yeah, you're using port 9002 where the filter defined 443. Yeah, good catch. It's just because I'm actually using network address translation. So I'm going through this public IP and this port, and it's translated into an internal IP address. So it's just nothing else than a firewall rule to translate address to get to the lab. So yes, it's a bit confusing, but it's pure NAT, nothing else. Okay, let me see if there are other questions. Okay, I don't see any further questions. So thank you for joining the session today. I hope that you liked the demonstration of Flowmon Packet Investigator, and let me wish you a successful day. Thank you for watching and see you next time. Bye.